calculator tomorrow. I have not decided, especially since I just have realized that I used the quiz and now I'm going to have to go back and redo this and pick from one of these two and put another question with it. So last time I gave this, I let you use the calculator. The calculator really doesn't help you very much anyway, other than you can get a decimal for your answer. So I'll just see. Probably depends on whether or not the second question I give you is calculator active or not. I think I just let them use the calculator because the second question was calculator active for this one. And the calculator really does not help you much on this problem at all. So, ship A is traveling due west. There's ship A. Ship A is traveling to the west at a speed of 15 kilometers per hour. So they have labeled this side of that triangle as X. We have a speed for that, so keep that in mind. Ship B is traveling due north away from the lighthouse rock. So B is going in this direction, away from the lighthouse rock, at a speed of 10 kilometers per hour. Let X be the distance between ship A and the lighthouse rock. That's labeled for you here on the picture. At time T, let Y be the distance between ship B and the lighthouse rock at time T, as shown in the figure above. We are supposed to find the distance in kilometers between ship A and ship B when X equals 4 and Y equals 3. This is an old question. They would probably not ask this as a separate question anymore because there is no calculus in this question. They're not asking you about rates of change here, right? They're just saying if X equals 4, X equals 4, and Y equals 3, they want the distance in kilometers between the ship. I'm going to call that C right there. This is just a straight Pythagorean theorem. Not only is it Pythagorean theorem, it's a super easy Pythagorean theorem. Anybody know what it is right off without doing it? It's going to be 5. It's a 3, 4, 5 triangle. Really common, the one that we see. So much so that I think if you just wrote C equals 5 without any work, that they would give it to you. I don't think they're going to ask this as a separate question anymore. This is an old problem. But you are doing 3 squared plus 4 squared equals C squared, which is 9 plus 16 equals C squared, 25 equals C squared, and you get 5 kilometers there. I don't think they'll ask that as a separate question. I think you'll have to do that as part of your work for the rest of the question if you were to see something like this. Now, if you see it on tomorrow's quiz, I'm just putting it exactly like it looks. This is only worth 1 point, but there should be a fairly easy point for you, right? And like I said, because it's a 3, 4, 5 triangle, I would not even require work for that part because it is totally reasonable to think that a calculus student would know that if the 2 legs are 3 and 4, that the hypotenuse is 5. So we have that. So we are supposed to find the rate of change in kilometers per hour of the distance between the 2 ships when X equals 4 and Y equals 3. Okay, so in this particular case, X is changing, Y is changing. I have decided to use the letter C right here for that hypotenuse. You could use a different letter. Any other letter is fine. Just don't use X or Y because I've already used those. And so this is a Pythagorean theorem problem. But we need to think about what we know because right now we've got X squared plus Y squared equals C squared. We need to think about what we know to see if we need to change this to where we only have 2 variables or if it's okay like it is. First of all, is there anything that we can just plug in because that value is constant right now? Like any numbers we can plug in before we take the derivative. Both ships are moving, which means all of the lengths of the sides of these triangles are going to be changing, right? So we cannot plug anything in ahead of time. Also, they gave us 15 as the rate of the speed of ship A. So, it is a speed, which is like a velocity without a sign, right? Or a rate of change. How would I represent that as far as like the equation, what I'm going to see in the problem? D what dt? dx dt. Now they gave me speed. Speed's always positive. Is x increasing or decreasing? The length of this bottom side. Decreasing because the ship is moving towards the rock. So we'll have negative 15 for dx dt. They also gave me 10 kilometers per hour here for ship B. So that is going to be, the ship B is moving away from, that's going to be dy dt. And is that going to be a positive rate or a negative rate? Positive, because y is getting longer, right? So I've got dx dt, I've got dy dt. I know x, I know y. I can find c. They already had me find c, right? And they're asking for the rate at which the distance between the two ships are changing. Find the rate of the distance between the two ships. That is dc dt is what they're asking for. So I have enough information here that I don't have to change any of these variables because I know the rate of change of everything except for the one I'm looking for. So I'm going to have 2x dx dt plus 2y dy dt equals 2c dc dt. And then I can plug in my values. So I've got 2 times 4, and we set up there that dx dt was negative 15. I've got 2 times 3, and dy dt was 10. And that's going to be 2 times, see here normally we would have to find c, but they already had us find c in part A. So we got 5 for c at this moment whenever x is 4, y is 3. And then dc dt is what we're looking for. Right, so if I let you use the calculator on this, the only thing it helps with is this like pretty easy multiplying. So you may or may not see that I'll try to be able to do it without a calculator. It's all going to depend on that second question, on whether or not I'll let you use a calculator. So here we've got, let's see, 2 times 15 is 30, 30 times 4, we got negative 120 right there. Here we're going to get plus 60 equals 10 dc dt. So that's going to be negative 60 equals 10 dc dt, and we will divide by 10, and so we got negative 6 dc dt. This is an old question where they gave you the units. There's a chance they might ask you for the units in here. I would write the units. You got negative 6. That is in kilometers per hour. There. The way they've worded it, they say just find the rate of change, so you don't necessarily have to write a sentence for this. You could say the distance between the two ships is decreasing at a rate of at a rate of positive 6 kilometers per hour, if you use the word decreasing. Okay, so then they're going to ask us to do a different question, right? Same scenario, different question. They have marked this angle right here, and they have said, let theta be the angle shown in the figure. Find the rate of change of theta in radians per hour when x equals 4 and y equals 3. So if we're throwing an angle in there, that switches this from Pythagorean theorem to, what should we use? Trig, right? And so for this angle right here, the ones that we know and care about are y and x, right? So which trig function should we use for that? Tangent. Now, I guess you probably could, because we just found c and dc dt, I guess you probably could use any of the trig functions and use sine or cosine, because we do know c and dc dt at that point. But if you do that, you're relying on the answer that you got in part B. So I would somewhat discourage you from doing it. Although it is easier to take the derivative of sine and cosine, so I mean, like, it's not the worst idea in the world. But I'm going to go with just tangent here. So tangent of theta is going to equal, what is it, y over x, y over x. Now, this is a little tougher because both of these, everything's changing here, right? We don't have any constants. So what are we going to have to use when we take the derivative of the right-hand side? What rule? Quotient rule has to be used here. So the derivative's a little tougher. Derivative tangent is secant squared theta d theta dt. Don't forget that d theta dt. Over here on the right side, you have to use a quotient rule. We haven't really seen one where we had to use quotient rule yet because we usually got to plug in a number somewhere, right? So we got to do x dy dt minus y dx dt all over x squared. So it's not a terrible quotient rule, but you do have to remember to use it there. Okay? Now, we're going to have to plug in. Now, here is where this one is a little tricky. Okay? So, if I think of the things that I know, like I'm going to highlight it here, think of the things that I know. I know x is 4, so I know x. I know that y is 3, so I know y. They gave me dy dt up there, right? They also gave, I know the speeds of both ships. I know dx dt. I forgot to highlight this x right here. I know all of this stuff. That's good, right? I am trying to find d theta dt, right? Because it says find the rate of change of theta, right? But what do I not know? I do not know theta, okay? Which is not our easiest to find right here. So, but what you want to do here is you don't actually want to find theta. You want to find secant of theta. So, what you can do here is you know that this bottom side right here is 4. You know this side right here is 3. Let's see. Kaylee got a note for me. Okay, I'll just check with him. All right, so here, if theta is my angle right here, I know at this time, this side right here is 5. So instead of trying to find like the actual angle, because those are not unit circle values, like, you know, tangent is 3/4, that's not like on the unit circle, we can't really find the angle. But I know that secant, well, actually, let's think about this. Like, remember, sine is opposite over hypotenuse, right? SOHCAHTOA, right? Cosine, here's the one we really need, is adjacent over hypotenuse. Secant is 1 over cosine. Secant is hypotenuse over adjacent. Because whenever you have 1 over cosine, it just flips cosine, right? Dividing fractions, easy as pie, flip the second and multiply. So secant is hypotenuse over adjacent. So secant of theta here is the hypotenuse, which is 5, over the adjacent side, which is 4. The square does not go away. So what's happening here, this really just means secant of theta squared here. That's what that notation means. So when we have that, we're doing 5/4 squared d theta dt. And then we've got numbers to plug in for everything over here. So we've got x's for dy dt was positive 10 minus 3 times the x dt was negative 15 over 4 squared. Now, if I end up not giving you the calculator, you technically could just divide both sides by 5/4 squared and leave it. You don't have to simplify, but I'm going to simplify. I think, especially whenever these are the ones you've seen before, I think it's easier to be able to know the exact answer that you're trying to get to. So 25/16 d theta dt is going to equal 40 plus 45/16. So 25/16 d theta dt is going to equal 85/16. I would like you're trying to divide by 25/16, but I would just go ahead and multiply by 16/25 here, because dividing fractions is easy as pie. You can just flip the second and multiply. So multiply both sides by 16/25. The 16s cancel, and so d theta dt is going to be 85/25. If you want, you can reduce this. I wouldn't. I'd leave it. And this would be radians per, what were we doing? Hours here. Radians per hour. Okay. That second part of that's a little bit trickier. And I think the trickiest part is remembering what to do with your secant part there. Okay, questions? Yes. We know secant of theta is 1/cosine of theta. That should be one of the ones that we have memorized from pre-cal, one of those trig identities. So that means that secant of theta is 1/cosine is adjacent over hypotenuse, like that. So dividing fractions is easy as pie. Flip the second and multiply, and so you get hypotenuse over adjacent whenever you do that. And whenever we learned those identities, they were called the reciprocal identities. They're called the reciprocal identities because secant and cosine, if you just flip them, you get the other, right? So if you have secant, you can just flip cosine to get secant. The same would be true for sine and cosecant, or tangent and cotangent. They just are the flip of each other here. Okay, anything else on those? All right, we got time for one question at least on our next. What I've put in here, most of the problems that I'm giving you here are going to give you the equation, right? So we've got particle motion, we've got fuel consumption, we've got Boyle's law, we've got a table problem, but in these cases, in a way, they are going to be easier because for most of these, you don't have to set up the equation. So coming up with, oh, this is a similar triangle, and I got to do this over this equals this over this. You don't have to do that part. So that makes it a little bit easier, but sometimes the derivatives are a little more difficult because they're giving you an equation. Now, sometimes they do calculator active, so then they're not even that hard either. It just depends. In this case, a particle moves along the ellipse. at a certain instant, x equals 2, y is greater than or equal to 0, and dy dt equals negative 3 units per second, which is true about the value of x at this instant. And this is going to be a calculator active problem. We can tell that from the answer choices that I should have probably put a calculator here, right? So it's going to be a calculator active problem. But you are still going to have to do some of the work by hand, because the calculator is not going to take the derivative of this for you because it's an implicitly defined function. Right, so they can safely let you use the calculator and still test if you know how to take a derivative here. So I would, for this problem, think of this as 1/9 x squared plus 1/16 y squared equals 1. You're going to take the derivative. You will get 2/9 x dx dt plus 2/16 y, but 2/16 will reduce to 1/8. If you leave it 2/16, that's fine, though. It's not going to hurt you. dy over dt equals 0. So they tell us, I'm going to get my highlighter out here, they tell us that x equals 2, so I can replace this x right here. They tell me y is greater than 0, but that's not helpful for finding an actual value, right? They give me dy dt, and then they don't tell me exactly what I'm looking for, but if I look at my answer choices, the value of x is increasing at a rate. What is that referring to as far as my equation goes here? That's dx dt. We're finding dx dt, right? So find dx dt. So that dx dt is what I want to find. I don't want to replace it. What am I missing? Y. So I'm going to have to plug my numbers into y. I know x is 2, so 2 squared over 9 plus y squared over 16 is going to equal 1. So that's going to be 4/9 plus y squared over 16 equals 1. I will subtract 4/9 from both sides. I'm running out of room here. So I got y squared over 16 equals positive 5/9. I will multiply both sides by 16. This is a calculator active problem. So let's see, 5 times 16 is going to give you 80 over 9. You will square root both sides. So the reason they tell you y is greater than or equal to 0 is because right here when you square root both sides, you're getting y equals plus or minus the square root of 80 over 9. But we want to choose the positive number. So I can plug this information in. I've got 2/9 times 2. dx dt is what I'm trying to find, so that does not get replaced. Plus 1/8 times y, which is going to be the square root of 80 over 9. Or go ahead and give decimal for that if you don't like having that square root of 80 over 9. And dy dt is negative 3, and this is supposed to equal 0. Right? At this point, definitely go ahead and pull out the calculator here. So I do know 2 times 2/9 is going to be 4/9. You can go decimals if you want here, but I'm not yet. But I am going to go decimals for this other part. So I got 1/8 times the square root of 80 over 9 times negative 3. Ooh, make sure you're on the outside of that print. Square root negative 3. So I'm getting negative 1.118. It's supposed to equal, oh, sorry, this was a plus sign, equals 0. So I'm going to move this 1.118 over to the other side. I got 4/9 dx dt equals positive 1.118. And last step is to divide by 4/9, and this is calculator active. So I am just going to flip over here and do 1.11803398875 divided by 4/9. And I'm getting 2.516 if I round. Oh no, this is not good. Is my problem bad? I think my problem is bad. Does anyone see a mistake that I have made? I feel pretty good about it. Radians or degrees shouldn't make a difference here because we didn't have any trig. I think I just made bad answer choices, probably. It's 5 times 16, 80. Let's make sure that 5 times 16 is 80, isn't it? Yeah. Yeah, I didn't mess that up. I think that I just have a bad problem here. I think that if I go over here and change this number to 2.516 and then change this number to 2.516, now we have good answer choices. I'm pretty sure I've done this right and my answer choices are wrong and I need to go back and fix this question, even though I've used this one before. So this probably happened last year. And then I said to myself, go fix this, and then I didn't go fix it. It's probably what happened. Would this x value be increasing or decreasing? That dx dt that I got is a positive number, so the x value is increasing at a rate of 2.516 units per second.